Hello from Rome, Precalculus students. I hope you had a good winter break and are ready to roll as we start the new year. So, today's lesson is going to be about the law of sines. This should be something that you saw in geometry, briefly. Basically, this is going to be used for solving oblique triangles. Those are triangles that are not right triangles, so a triangle that does not have any right angles in it. And that's because if we had a triangle that had a right angle in it, that we could just use simple trigonometry, sine, cosine, and tangent, in order to find out a missing side. So when we're working with the law of sines, we generally label the opposite side to the angle with the same letter. So if this is angle A right here, then across from it is going to be side A. Similarly, across from angle B is going to be side B, and across from angle C is going to be side C. So for solving triangles, meaning finding all of the missing sides and angles, there are going to be two different laws to use. There's the law of sines, which we're going to talk about today and tomorrow, and then there's going to be the law of cosines, which you're going to see on block day. And they are for different scenarios. So the law of sines is for the scenario when we have a pair of opposite sides and angles. In other words, we need to know about angle A and side A, or angle B and side B, or angle C and side C. We need to have an opposite pair of angles and sides to be able to apply the law of sines. So that means it's really useful in certain scenarios. If we know two angles and a side, for example, if we know angle A, angle B, and then either side A or side B, then we would have B with B or A with A. Either scenario would give us exactly what we need to work with the law of sines. But it also works in the ASA scenario. That's when we have, let's say, angle A and angle B and side C. So while we don't technically have an opposite pair of sides, we actually do, because if we know angle A and angle B, then of course we can find angle C, because the three angles are going to add up to 180, and then we'll have the opposite pair that we need to work with it. And then the other scenario that we have that can work for the law of sines is the side and angle scenario, and we will talk about that scenario tomorrow. It's a little bit more complicated because there are multiple triangles that are possible in that scenario. So we're going to talk about that scenario tomorrow. It's a very sloppy tomorrow. There we go. That made it completely better, right? Okay. So looking at our law of sines. So what the law of sines is, it is a ratio, and it is a ratio that states that A over the sine of A is equal to B over the sine of B. So that the opposite pair of the side and the angle are together within the ratio. And it is also true that these are all going to be equal to C over the sine of angle C. But really we're only going to be looking at two of these at a time. And so we're not going to actually have this full triple-decker equation to work with. We are going to simply be working with two of them at a time, or two of them at a time, or even those two at a time, but we're going to be looking at them two at a time. And then since these are just ratios that are equal to one another, we can actually flip it and look at it in another way, and because sometimes it's convenient to have the angles on the top, so sine A over little a is equal to the sine of angle B over side B, is also a valid way of doing it. And of course we can also have it equal to the sine of angle C over side C as well. We can set any two of those equal to each other. It works both ways with the sines on the bottom or the sines on the top. Okay, so for our example, we're going to solve a triangle whose angle A is 30 degrees, angle B is 45 degrees, and side A has a measure of 32 feet. So that leaves us with three things that we need to find. We need to find angle C, we need to find side C, and side B. So we can do that in almost any order. Personally, I like to find angle C first because that's the easiest calculation that we're going to have to deal with here. So that is going to mean we're going to be doing angle C is going to equal 180 degrees minus the two angles that we already know about, 30 plus 45. So that's going to allow us to calculate that out. That's 180 minus 75, or in other words, 105 degrees. So that takes care of one of the three things we need to find. And then to find the other two, we're actually going to need to apply the law of sines. So in order to find, let's do angle B. In order to find angle B, we are going to need to set up our ratio. And so that's going to mean we want to set up side A over the sine of angle A equal to side B, which we need to find, over the sine of angle B. And that's going to give us our starting ratio. So, a couple ways that we can look at this. It's a proportion, so that means that we can look at this as cross multiplication if we want to. That the two crosses will be equal to one another. So we could set this up as B times the sine of 30 degrees is equal to 32 times the sine of 45 degrees. And then all we would need to do would be to divide by the sine of 30 degrees from both sides. And that will leave us with B is equal to this particular calculation. And so the actual calculation then, we would type that into our calculator, and we could get our B value equal to approximately 45.255 feet. Please round off to 3 decimal places. When we are approximating our answers. Okay, so if we take a look at trying to find side C, again, we're going to need to set up a ratio. I'm going to go ahead and use the same 32 over sine 30 degrees equal to side C over the sine of 105 degrees, which was the angle that we discovered earlier. And then we can set up our cross multiplication similarly. We're going to get C sine 30 equals 32 sine 105 degrees. A little sloppy, sorry. And then divide by sine 30 again, in this case. And that's going to allow us to find side C. Type that into your calculators. And 32 times the sine of 105, make sure your calculator's in degrees mode, of course, divided by the sine of 30, and we would get a 61.819 feet as the result. So, for working with these law of sine problems that you'll be doing today, you're going to start with two angles on one side, and we can find that third angle once again by subtracting from 180, just like we did up here. Subtract the two angles that we already know from 180 to get the third angle. And once we have all three angles, then we can set up our proportions in order to solve for the two remaining missing sides.